I guess we'll find out. If I don't have the right stream key, it would be because YouTube changed it on me for no reason, and that doesn't make any sense. Oh, hello. Okay, something happened. YouTube is sick today, it's falling over. It claims there's a good connection, but there's nothing showing on the screen. So, let's see what we can make happen. I'm going to fool around with some of this other stuff while I'm at it. Like that should say live chat. And I do not get why I'm getting a black screen. There's no good reason for that. We'll try that again. So starting streaming, and my settings shouldn't have changed. And in the YouTube Studio interface, oh, haha, we're live. Let me set the image to what I want it to be. Man, YouTube complains a lot about all this kind of stuff. Either that or I'm looking at a very delayed stream. We'll get there. I have a plan as far as what I'd like to do today. And I have an idea for a plugin that I could try. One that will be sort of based on bandpass, but not exactly like bandpass. So it might take a little fussing around and coding, but I have a fairly clear idea of what I'd like to get done, and we'll sort of crack onwards and see how much of it we can get done. Double check that I have live chat. Yep. So here's where we're going to be working. So here's the thing. We're going to call this XRegion. I am set up with my usual workspace of being able to like make noises, and if I make a Live Distorty plugin, I'll be able to turn that up, and I can use various different things for that. I was going to do some of this in advance and I didn't end up getting to do it, but let's see what we got. So XRegion, I believe that the title for this one is going to be like XReg. The white space can be anything. I don't think it cares, but I'm just having this white space be orderly in a way that I like. And we're going to, I think, start off by defining it in a different way. We're going to build this as a clone of X bandpass, but with 2 frequency settings. Because here's the thing. I have in mind to do a set of bandpasses that overlap each other and not all be the same frequencies. At first I want to hear what that sounds like, and I could do that with just X bandpass, but I also want to make an interface. Hang on. Screens are weird, man. Set up the screen in such a way that you're glancing over at something And if you see a little tiny face moving and looking around, you're like, look at that. And of course the camera is here. Eventually, I've been doing that for how many years? I'll eventually learn how to do it. So we're going to start with stuff like this. The regular bandpass filter has 5 different bandpasses in it. So we'll be duplicating that. And we'll be duplicating some of this, but not exactly the same way. We'll take that, but we're also going to be adding an extra control and sort of moving everything down one. So it'll look like that. And then same thing for the names. Do this properly, and it'll be a bit of a head start because I think I'm going to want to, and I'm not sure quite what's going to be easier here, but this is probably the easiest. And we'll say maybe the high frequency one is on top and the low frequency one is on the bottom. And keep going. Hey, starting to see some live chat. Parallel, huh? That's interesting. I'm not actually going to be stacking these in parallel. This is a different concept which will involve stacking them in series, which is how they're running currently. My idea is that this is going to make the distortion characteristics interesting, but we'll start out with basically just some offsets and then come up with what works, if in fact it does work. I'm not spending a terribly large amount of time explaining all of this because I kind of want to get something up and running as quickly as possible so there's something for you to hear. Those are all going to be the same. This needs something in it. Reset needs to be a thing. By the way, I hope folks have enjoyed Notch. Oh. Else, do you mean this one? Like literally the one that I'm working on? Here's the deal. X bandpass is a single bandpass filter. So the frequency response will be like, whoop. And it's Butterworth, so it's kind of a tilt there. As you increase the nuke function and start using more poles of filtering, you start stacking them in the same place, and so that filter is going to become steeper and steeper and steeper because it's filtering it more. David, hey, filtering it more. Region is about stacking them in the same way. If they were in parallel, you wouldn't get it any steeper, but if you run them in series, that's called running it as multiple poles, and it'll make the cutoff steeper. But if you took several of them and put them side by side, in theory what's going to happen is the end roll-offs are going to be just as steep, but the area between the frequency positions of these series bandpass filters will blend. So in theory, if you stack them up well enough, it would be really steep, and then it would be kind of flat or something, and then steep again. And that's the idea. Now, the trick here is these are distorting filters. So the question becomes, if each of those are also adding distortion, how does that interact? And basically the easiest thing to do is to try it and find out. So that's what we're going to do. I'll go back here. I don't really work with instruments, although at the point that I start having a toolkit where I can build a AU and a VST synth, that's something that I could start experimenting with. That hasn't happened yet. And this is recent, so it has all the same code as far as template code is concerned. And so what we'll do is we'll take literally everything here, copy it in. We should now have a working copy of bandpass named XRegion, except for we're going to make one small change. And that is this. All these now apply to other controls. And let's see now. Okay, so that was 3, so this also is going to go to 4. And now we have a little gap. We have another thing here. And this will So this part is no longer going to apply. And that's because all these parameters are going to run slightly different for each one, because all these are going to have slightly different frequencies. So I'm going to have to go through and basically do this 5 times rather than just once. I can simplify that by deleting this bit because we don't use it. Pretty much immediately I'm going to need to use this, so let's see. Although one thing we could do is test it and make sure that it does actually run. If I've made any really silly mistakes, this is a good time to find out. That doesn't count as not actually running. When I build a new project in Xcode with this particular template, first time it builds it, it tries to do the project before it's built any of its dependencies. So you build it once and then you build it again, and then it's fine. I changed nothing, it just worked the second time. So let's go see whether that worked. We'll reacquaint ourselves with the bandpass. There we are. And that's sure as heck a bandpass. And like I was saying, when you add nuke, we're adding some gain. And this is also a weird version that it distorts inside the filter. So it's doing a funky thing. Now the question becomes, is it going to continue to do this funky thing if the frequencies are at all different frequencies? These gains seem basically okay. of the things happening here, oh, hang on. I don't think that that should seem that quiet for you. I mean, we're practically distorting here. So the idea is, I want to make a variation on this based on the concept of a region where you've got a range. Maybe they all are going to be based on the full range, like nuke all 5 spots. But you could have the lowest one being down here and the highest one being up here by positioning them like this. And that spread will have all the filters in it. And then as you dial back nuke, maybe it simplifies matters, and so you wind up... The thing is, the way I've got nuke set up is you're getting just the first layer of filtering here, and around here maybe we're getting into 2 layers of filtering, and so on. So by the time we get way up there, like the difference between 4 and 5 poles of filtering is all over here. So here's the thing we could do right from the beginning is let's alter that. I'm going to find out where that was happening. Or maybe it wasn't. Like, see, that's coming from get parameter param4. That's our nuke control. So this is get parameter param4 times 4, meaning that it's not actually, like clip factor is increasing at a particular speed. That's our distortion factor. And we can change that around a lot. We can have that behave very differently. But we are getting a fairly even spacing between only 1 pole on one end and 5 poles on the other. Now, region is only really going to make sense with multiple poles, so I kind of have to see how that works. And I think the first thing we're going to do here is this assigns all the different filters. So the first thing we're going to do is assign those filters manually. That's going to look kind of like this. So plane A, B, C, D will be all of them. And now I got to go and change that for all these different guys. So I'll step through that. It won't take terribly long. You can come up with clever ways of doing search and replace on them, and I'm not going to bother. Just have to remember to step over and get this one here. And then A is fine. B is going to be this next one. Let's just do this stuff. Hang on. Do the stuff that I can do with the mouse this way, and then I'll do the stuff that's more keyboard oriented in a moment. So a little keyboard dance there. Oh, didn't want to do that. And now we are assigning all of these manually. Now, one of the things we do have to do, however, we can test this out to find out whether it worked. And maybe we might even want to make these be individual as well. In fact, that seems like a clever idea. Let's do that. He says as he pauses. Yeah, that's going to make sense. So basically, this section is the section I'm going to want to repeat and have set to the same thing for starters, and then we're going to come up with a way of making it more interesting than that. We are, however, starting with the ability to define two different positions for this. So let's, as always, into that no word zone. Start fumbling with my words, not making any sense. Hopefully, if you're really sharp, you can maybe follow and see what I'm doing without me having to explain it. This stuff is going to be organized in such a way that it's in the similar way that I define it already. So now this is okay and this is okay. I will need to define all of these things because all of them are getting referenced by their respective calculations. And now I go through and do the same thing for all the others. In other words, B in all these places. And same thing for C. And then I'm going to test it out and make sure that everything is still functioning before we get into the actual meat of the process. Also, I'm not quite done here either. You can probably look ahead to see where I'm going. This is C, literally. So what we're doing here is defining all of these, but they're all referring to the same control. So in theory, it should all act the same. And our compensation isn't going to be quite the same in the end result. In fact, here, hang on, I've got an even cleverer idea. Or at least one hopes. Sometimes looking stuff like this up is slow, but even if it isn't, I can think of something I want to do separately. You can probably see where I'm going with this. And I'm still not quite done because there's another thing I have to attend to as well. See, if I have this, and these are no longer that, but over here, this, it's still going to act the same, but I have more flexibility for redefining this later. That's what you might call refactoring, which is this is defined in a different place so that I can make this a little algorithm in here that incorporates this other control. And it's basically going to go from one end of the calculation that happens first is going to be one of these, and the other end of the calculation is going to be the other. And then the ones in the middle are going to blend. But I said that I wasn't quite done. That's because there was something else I had to remember. See how I have assigned compensation C, compensation D, and so on and so forth. Well, all this stuff here is still just regular. And the reason I need to make those separate is that they're going to be operating on different frequencies, each of which will have their own little scaling. So I have that happening in those places. And all of this is still going to end up doing the same thing, we hope. But I've just made it so that a very small change can produce a large effect, because a bunch of different things are now split off into their own little sections. All these parameters are being calculated individually rather than copied over from the central one. And I forgot a thing, so let's go fix this. What I need to do here is take out this part, because I forgot to take it out. Hey Lorenzo, well, hey everybody. And that's fairly straightforward, it's just a little bit more busy work. Because here's the thing, once I've defined these and used them here, I don't need to use them again, so I can just redefine them. You know, the fact that I had values in here doesn't matter, because I'm moving on to biquad A and we're using a separate version for that. And likewise for biquad B, gets its own dedicated K and norm and does these calculations in its own right, and so on and so forth. Having finished these, it should work. Or at least built. We're still testing to find out that it worked. I'd be a little surprised if it didn't, but that sometimes you miss something, so let's find out. This should be acting the same as it did previously. It's not the same inside, and in fact it is less efficient inside because we're now calculating everything slower. So the thing that's interesting about this, like this control is going to start to make a kind of blend between the two regions. And we've got our little nuke. If we take that away, we've technically only got one bandpass anymore. So I don't really have a very sophisticated way of doing this, but I might be able to figure out something clever. The idea is, however, that it can be centered on something. And maybe what would be good is if you had it set like this and you had only one in the nuke, it would place the one pole one around here. And then as you started adding more, you'd get more and they'd start distributing themselves and so on. Or it could just follow the high one, and then we'd start adding, as we add nuke, you'd have 5 that are added one at a time. So this would be this one, and then if you had the frequency low all the way down here, 1, 2, 3, 4, 5, and the 5th would be what this one is set to. That'd be easier to do. And it does seem to be behaving, it does seem to be working. So I think the next thing is to just punch this variable in somewhere and see whether we can kind of combine them. So now we've got 3 high frequency bandpasses and 2 low frequency bandpasses. In fact, we can even split it. Let's have it balance. If we have high plus low times 0.5, we have the average of high and low. And so the middle one literally sits between the high and the low. And now when we build this, both of those knobs should do something. And I'll begin to hear what might be happening with this. This is our first chance to hear what I was going to try to make happen. There's also the possibility that I will need to take out the weird quirkiness in the behavior and have it act more like XNotch, where it is a simple distortion rather than a distortion that makes weird artifacts. But that depends upon how well it behaves when we do this with it. So can you tell what's happening? We have these two band passes, and it's running in series through the band passes. So it's running through the high frequency ones, and those are still loud and distorted. But then we're filtering that out almost completely because the low frequency one is so far down. And so we've cut our volume so that you can't even hear what's happening. But if I move the low frequency one towards the high frequency one or match it, this is back to what we had before. And with this, we can actually hear the sort of laser noise of the filter freaking out. Now let's listen to what happens when we start spreading these out a little bit. Let's hear what happens when we go the opposite way. That's interesting. I was expecting the other way around to go better. And if we reduce the nuke, the ones on the end will be left off first. So we're only hearing this first control. As we increase this up, we start bringing an interesting side effect here. If we have it spaced out enough, we start bringing in one that has more spacing, and then we bring in this high frequency one, and it's so far away that we're losing all the gain again, which is something that we could be including in that compensation factor. We could also add a kind of offset rather than spreading it between these two things. We can have the offset just say how much of a proportion there would be. But here, first things first, let's do a little bit more listening. I'm not quite sure what you were saying there, Aaron. As far as which thing sounds more interesting, because we have this loud effect because everything is on the same frequency. Now, if I cut this down, the high frequency is going to make the weirdest artifact. If I cut this down, we can really get the artifact to take over in an interesting way. So the question is, which departure is most interesting? In this one, we're hitting the low frequencies first, and those are causing that funny side effect. And the louder that continues into the other ones, the more they too will make a funny artifact side effect, but at a different frequency. Whereas with this, if it's hitting the high frequency one first, pretty much all we get is the artifact. Nothing else happens. So this is essentially turning into various ways to get nothing but artifact, and that's not really quite what I had in mind. Like we could do this, and that's all fine and good, but in some ways that's not exactly what I had in mind. Nor is this. It's like interesting. We have no sound available except for this freaky additional noise. And that's apparently what we get when we use this form of the bandpass with its weird little filter noise and spread them out. No matter how hard you distort it, you get nothing but that artifact. So I have questions as to how useful that is. We're certainly not getting much useful out of that, so I'm wondering whether maybe next good thing to do would be to... Oh, I haven't done anything with LV2 format, but all of my stuff is open source and very neatly arranged, so anybody who did want to make LV2 would probably have an easy time of doing it. Where was I? Anyway, this stuff works, but what would happen here, I think maybe I have, let's go and find Notch. XNotch, AU version of XNotch. I think this is a good example of, let's go and see if it is. Ta-da! That's the part I'll need. Because it's looking very much as if I can't do XRegion the way I was imagining as it currently stands. XBandpass is very much centered around using those funny artifacts. As soon as I start spreading out the position of the knot of the bandpass, the artifacts essentially take over. And they're so intense that everything else goes away, and that's really kind of not what I had in mind. So what we're going to do is this. XNotch is based on distortions that live here rather than inside the filter. So as a result, they're not doing the weird thing that happens in the filters of the old samplers and stuff. It just happens to be a useful sound. Might be a good time to kind of repeat that. That's the only part that I need. We'll close out of there. And boom. 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 And just for fun, let's see what that sounds like before taking out the other distortions. We'll double distort everything. Let's see what we got. If it's amazing, maybe we'll accidentally have something awesome. although very pricey because it'll be like 10 sine calculations per sample. Could be a fairly demanding plugin to run. We'll see whether the little old antique laptop falls over. We might be asking too much of it, especially in a 96K file, which this is. Let's find out. Okay, we can get a bit of a sense of it. This is still getting loud enough that we can get the freaky warbly stuff going on. But because of the way that it works, we can kind of hear the range in it. So let's continue the process. We're deleting the distortion factors, and we are deleting that clipping stuff. Although there's situations where that could come in handy, but let's find out what it's like without it first. Okay, now this is the same as I have in XNotch. This is the distortions not happening inside the biquads. So, still without having done anything more sophisticated, let's see what we got. Also note that these are distorting in sequence. And that's really what I wanted to figure out, was what do various things sound like when you're going into multiple bandpass filters, all of which distort, but you can have either the high ones or the low frequency ones distorting first. Because the output of each successive bandpass filter is also providing an interesting aliasing suppression where overtones are going to be bandpassed again as they go through. So all the multiple band passes are just kind of like the Focus plugin, only to the nth degree. Enough talk, let's hear what it does. Okay, we can be loud. If we voice things too far, we get like no audio anymore. I do end up losing gain on this. In theory, you could just keep boosting gain more and more and more and counteract this behavior. We sure do have a strong effect. Oh my goodness. Look at that number. I think you can see the number on the screen. Here's how much we're peaking past zero. 18 dB. No, 30 dB. That's a lot of gain. And then you spread it out far enough and you can't hear anything anymore. So that's interesting. So essentially, this is bandpass filters feeding into each other in series. If I spread them out far enough, I lose all the gain. because I have no compensation for that. But I could come up with a way of compensating for that. And the overall gain, I'm definitely going to have to make something about this. Let's find out what we can do. There's no point going any further without at least trying to do something about this. So compensation D, all these compensations are correct. Let's see where they're being applied. Compensation means input sample equals output sample divided by. So that being smaller is going to make the output louder. That being larger is going to make the output smaller. So and it's square root by quad c divided by 4, so or times 6.4. So basically this is something that gets tiny as the frequency of the relevant thing goes down. Let's quickly make another variable. Now we've got something where if they're the same position, it could be as low as 0. And then if we're using anything else, so the wider it goes, the larger a number that becomes. This also means we can't divide it by 0, and that could be a limiting factor. So we're going to be applying it probably in compensation. Larger number means make the result quieter. Compensation, larger number means make the result quieter. So if we had, say, this, what we would get is as the frequency goes down for any one of these, its compensation gets smaller, and as the so that could work. Let's do another thing. Let's see, we're going to what, 4, 5? Yeah, so 6, which is not labeled yet, is free to be used as a thing. And since we're multiplying, 0 is permissible since we're multiplying. It's not going to crash. And so get param 6 could be 0, and that'll still be safe. It's always going to be 0 or something higher because it's absolute high minus low. And if get param 6 is cranked up all the way, spread is always going to be 1 or more. Multiplication is commutative, so we can just tuck this in wherever it's needed. And this might be the adjustment factor we need for this. We also might want to change the lowest frequency, but that'll depend. Let's quick run this and see what we got. I keep on thinking about like, oh, this makes this larger and this makes this smaller and this will adjust this and that and the other thing. And sometimes it's worth just seeing what it does. And people are allowed to dislike this stuff. It's not for everybody. Goodness gracious me. Back in the day, I did an experiment once where I wanted to find out whether people disliking the videos and things gained you anything. And so I had everybody dislike on purpose for a little while, and it did no good. It doesn't actually help to have people dislike your stuff, but... Wow, okay. That's really loud. Wow. Maybe let's pull some of this gain back. It's so loud. Okay, we do have a control here where this basic concept works. I can make it be very loud here, and it can go to very quiet. I can turn it down like this, and it goes to very quiet. But if this is closer to down here, we got some adjusting to do. Let's kill the gain on the input so that we can experiment. I think this is doing something useful. A little hard to tell, it's so loud. So where are we at? So this is how we're doing that. We're still, actually, maybe this is a good time to... Yeah, here, check this out. We need to have high and low. Those are easy to calculate. They're not really dependent upon each other. But if we... Let's add one more. Because if we generate this, which we could do here, we can use it in here too. There. Now, if I've done this correctly, I have 5 different positions for the frequencies. Let's see what we got, although we have not fixed the gain thing. The gain thing is still completely bonkers, out of control crazy. And that is because we're dividing by stuff, and so the smaller we make that frequency. So here's how this is working. Maybe I even have a fix right away. The smaller this gets, the smaller compensation will be, which means everything will get much louder. We're dividing by compensation, so we can't actually have spread be 0 because that just makes stuff too loud. So we can't actually crash the program and kill everything by having spread be 0, because then compensation is this various stuff. We've arranged that biquad 0 can never actually be 0 above. and then we multiply by 6.4, but then if we multiply by spread and it was 0, we would have a problem because we'd be dividing by 0 in the long run. So spread needs to be higher. So how is that affecting things? The split between high and low is the amount of additional boost we want to add. So that needs to make, as high and low go apart, that needs to make this number get bigger. Because the bigger the number is, oh no, hang on. No, as they move apart, the number needs to get smaller. That's actually not how that works. Let's put in a quick little sanity check, because some of this could get messy. I have no special wish to have everything crash. And let's make it an even tinier number, but that should be satisfactory. And if this is all multiplied by 1, it'll be back to what it was before. So here's the deal. And we could maybe calculate this differently too, but 1 minus fabs high minus low. Why are you giving me a menu all of a sudden? There should be, I have a better idea. Undo. So 1 minus fabs high minus low, which could be quite a large number, really, times get parameter kparam 6 times 2 means that if this unlabeled thing is set in the middle, it's acting the same as not having it be there at all, and it's just strict fabs high minus low. We do have it limited, so if you spread them too far apart, it can't actually be dividing by 0. This might be a fine time to see what we've got. Components. Okay, this is acting a little more like normal. Again, 0.5 means no real compensation here. We are getting louder as we separate more. So that's about the same volume level, whichever place we put it. Or maybe more. Now moving this other control is going to change the way that balances. If we have them at the same, no change. But if we separate them out, one direction should be louder and the other direction should be quieter. Let's find out which. That's louder. That's quieter. Alrighty. So we have something working out. Let's spread these even farther and see how an extreme of an effect we can get. We can get lots of distortion this way. and lots of attenuation this way. And if we set it around here, that's about 0.431 is what that is. I can hear it manipulating the biquad filter, so I can hear it kind of rumbling. Let's go into the lows. Now, would this be the same volume level as having these both in the middle? No, it's actually quieter. Also, remember, the way this works, it's distorting the ones at the high frequency position first. It should really be called freak first and freak last. Well, that was a weird noise it just made. Wow. In fact, that's such a weird noise. Let's hear it again. Okay, that's interesting. We've got lots of distortion in the low end there. And at this position, this mid-range stuff, I'm probably going to want to voice it into the mid-range and not worry so much about the lows. We're peaking like right up to +4 here. And then we can't peak as high when we stretch it too far. So we tweak this control and it goes more so. And again, low nuke means we're only looking at these high frequency ones. We'll gradually bring in more. I have one further thing to do. Seeing as this is such a spiky, punchy thing, I'm going to put in the end clip from XNotch. Because I had an end clip on XNotch because it was such a distorty thing. And that's pretty easy to do. It is here. So I can simply take that and put it in the same place on XRegion. Strangely, we don't actually need to assign nuke level on the final duet. That's an oversight. We'll ignore it because we're not going to be using it. It just came out of copy pasting, but it wasn't actually useful. So having done this, we're now not going to peak over 0. And one more thing while we're changing several things at once. Let's not lower our lowest frequencies down quite this far, I think. I don't know though, I could still play with it and find out. So all this stuff is interacting with the frequency. So 0.768 is the smallest amount of added gain. And then clip factor is what we're multiplying by here. So that's the amount of extra gain that goes into each of these. Then it's being boosted by this, but this boosts high frequencies more. Let's go down to 0.75 since we have so much gain on tap on the deep bass. If we pull this back, we're actually kind of attenuating a little bit more, and we're still adding as much as, half a 37. Because B quad B can never be more than 0.5. It is part of the biquad filter. The biquad filter can't go beyond 0.5 for this particular thing. And get param 4, which is nuke, can only go up to 1. So this stuff in here can equal almost but not quite 0.5. And then we multiply by 37, so our end result can be 0.75 times half of 37. That's a couple of changes. Let's see what we've got before I get confused and lose track. Probably worth throwing alien kittens or something at it and see what we get from that too. Because I like using things like drum. It's better than like white noise. But it's fun using stuff like drums in some of these, but there's also other test subjects. That was quite punchy. That was good and loud. Well, we got a Thundermaker. Ooh boy. Mine woofers are just, they're just vibrating away like crazy there. That was actually kind of excessive bass right there. Well, it's doing a good job of distorting lows. If I spread it, what do we get? Interesting. I can tell there's a lot of extra gain coming in when we move up to the highs, and so that algorithm might need to be tweaked a little bit more. Because what's happening there is, as we go up here, this control, which is in the very beginning, high is kicking in. And we have potentially too much possible gain here. Like, I do want it to get louder as we go there. We've also got some interesting effects. Is this still doing anything? Oh goodness, yes it is. what you get when all of the band passes are very distorted in their own right. But the one band pass, all of its stuff is being filtered and then distorted again. And if we reverse it, we're distorting the low band passes first and not the high ones. So if we do this, we have just all the this is all the nastiest distortion you can have. This is actually sitting at a useful range, interestingly. Let's quickly build that in. I'm not sure if you get what that meant. 0.5 times 2.0. 1.0 minus fabs high minus low. So that becomes spread. Spread can't actually be now I'm wondering whether maybe we can avoid this test. Because high minus low can never be more than 1. I think they go between 1 and 0. So that's as far apart as they can get from each other, regardless of which. Meaning we don't need to do this if we've done that. And that offset spread varies slightly, which is going to lower the gain of everything. Because spread going higher makes compensation higher, and compensation is what we're dividing by. So fair enough. Clean things up just a little bit, which means we're no longer using param 6 anymore. And we've got a nice little final output distortion. We are soon going to start trying this on actual music. That'll be even crazier. But while we're at it, let's just dive into the familiar drum sound one more time. Now that this no longer does anything, we have room for a little gain. This is like Berlin techno time, really. I think I can make more space here. Like, we don't need these frequencies. Or do we? So the way this works is, and one other change, we're going to call it first and last rather than frequent. And Nuke may or may not be useful for this one because it's not, I'm not sure how sensible it is to dial it back at all. let's play with it a little bit and find out, especially when we start using the other sound. Because that is actually as important as what the frequencies even are. And I'll tell you why. Big difference between how you arrange these things. That's kind of the whole idea. That's what I wanted to experiment with. This is what I wanted to find out. We got first and last. We got gain, we got nuke. So when we have all of these different things on here, like first, very simple distorted bandpass. And if they're the same thing, we can dial a bunch of craziness in, obviously. But as we start spreading them out, this is a type of tonality that nothing else is really going to give us, because let's make first be next to nothing. When we're distorting first, if we distort first and it generates harmonics, and let's make last. Okay, well that was fun. Definitely a lot of potential for things to go horribly wrong here, which is kind of the point. That's kind of the fun of it. As we bring more of these in, what's happening here is we're doing a bandpass filter in the very beginning and then distorting that, and then taking the results and doing another bandpass filter high up, which is only going to give us the distortion components of the first bandpass, and then we're distorting that and paying attention to the distortion components even higher up. Here, we can hear it pretty good here. Oh yeah, there's a lot of range. You go to the extremes and things go completely insane. So we can pretty easily hear what's going on here. We're hearing an initial bandpass, which is this. Everything is coming out of that. And then the output of that is going into the next bandpass, which is at a higher frequency and also distorting. And they just keep adding and keep adding. So that we're getting increasingly more band passes and increasingly more distortion every step of the way. Until the final one comes in, and it's at a super high frequency, so we can't even hear the super subs anymore, because it is, oh no, my birthday was June 5th. But So this is the experiment that I wanted to do with this, is what happens when you have a series of band passes that are staggered and you distort some of them first and they're in series. And this is what happens. You can make this ridiculously, atrociously trashy noise from, or, come to think of it, we could start out here and then have the last be cranked way up there. Very trashy indeed. And while we're doing that, let's turn it all the way up. We'll take it. Here's the other side of all that. That was using the first bandpass being set as low as possible. And then every successive bandpass is higher in frequency and catches more of the overtones. But if we do it in inverse order, so that the lowest bandpass is the last one and the highest ones are the first ones, we should be able to saturate in a way where the region, the stretch of the successive bandpasses each start filtering off more of the overtones and maybe get a nice saturated sound that doesn't have nearly as much grit. And that might sound something like this. We still have a kind of a chug going on. We have a lot of gain here. We do this enough and then we start rolling off highs rather than rolling off lows. Of course, as always, the more extreme settings we get, the more so that's a very heavily distorted sound. But it's a very different tonal quality than the other sound we were getting because it's backwards, it's the opposite. We're going into high frequencies first and then successively lower frequencies to the point where it almost sounds, well, we can get all the gain we want, of course. And we can sure get a lot of high, bright, sparkly noises too. Interesting thing is, because of the broad range of these, it's almost impossible to get real sounds out of it now. Interesting. So I got into a zone now where the highs are very distorted. And then I can continue bringing in more lower band passes. Just real gnarly. I'm seeing what else I can do. Okay, with this setup, it's kind of going crazy. It's just on the verge of exploding. Now, if I add some gain here, we can go from clean, and since the first ones are really high up in the high frequency range, we can go to a very distorted high frequency sound and then start muting it in a really distorted way. This has a real knack for being able to bring gnarly nastiness in here, which is all the more interesting since it doesn't actually have any distortion inside the biquad filters anymore. Weird. Let's play with some of these middle zones. So first being low frequencies gives us more of a emphasis on the distortion factors we're producing. Whereas the opposite we've got that broadened range, but the distortion qualities aren't as edgy because we're hitting the low frequency band passes last. Everything has to go through whatever the lowest frequency one is. This is kind of what you get out of if you're doing a guitar amplifier. You got your really bright input stages, your really bright input circuits, and then you're going through the power amp stage, and then you're going through a speaker which rolls off highs. And it's kind of like that. Let's play with Alien Kittens. Let's see what kind of horrible mess we can make with Alien Kittens. Let's find out. Oh, that sounds almost normal. Okay, this is definitely demonstrating what I was talking about. So full nuke, no special gain. Separate it out, we get a more bandpassy thing. Widen it and we sort of emphasize everything all at once. That's an interesting side effect there. I do have to wonder whether I'm spitting a lot of DC current out of this. Like, I'm betting when it chokes out like this, it's just because it's doing nothing but DC. So extreme settings are getting us craziness, especially since we're on full nuke. And first high, last low is a kind of weird, distorty wideband thing. That's kind of what it was supposed to be. No, it's not my birthday. I don't know what you're thinking. But check out what happens when we reverse it. This could be useful for people's like synthesizer pads or industrial noise bursts. Funniest thing is it's acting like a really insane filter sweep. Like if I had a filter in my Aero rack that would do this, I would use it. That's gnarly. Oh my god. That's what automation is for. I am, however, disappointed with how low frequency it's acting. Like that stuff down in the very lowest is not even useful. Let's amend that a little, shall we? Bump it up a little bit. This controls as low as it can go. That should give us a little more range of adjustment. And we could also change this power factor. See this 4 here? This is the power factor. So let's make all of these be 3 and see what we get. Because it's emphasizing the extreme lows so much. And if it was a 3, it's multiplying all of this various stuff by the power of 3 instead of 4, which means our low range is going to be more at the far left of the control, rather than being this big giant area sitting there just waiting for you to blow up your woofers with. And that's 2 little changes, both of which have to do with the low range. And let's see where we got. This is shaping up pretty well, I must say. I think this is working out pretty well. Alien Kittens, 44K I would add. Thunder still available. Oh my God, what the? Wow. That's a really gnarly noise. Wow. David, if you're still here, this is for you. Okay, I have to do something here. I don't know if David's still here. Pix the muzzle is David Pixley. I gotta do this. Now let's just see. Hang on. Where was that again? There we go. So. Funny thing is, this does not actually make it louder in its horribleness. All the same, though. Oh, I know. And of course, since ULAW is a decode-encode pair, if there's no departure from the original sound, it's not going to freak out or do an this is for him. Somebody will show him this later. But oh, there's some loudness. There, now we can isolate just that one note and have everything else be almost silent. Try. So the difference between this and the other one is that this is allowing some highs to come through. Or not. So XRegion inside ULaw. It does sound like trying to dial a radio into some kind of strange broadcast. Yeah, and since it's ULaw, if we do dry wet, small changes are going to have large amounts of weird distortion and dislocation. We get more of a departure here. We can do a sort of boosty effect here. Oh, let's do even worse. Kill the gain all the way. Add last up all the way. Find a good spot and then turn gain back up again. That's nice and spiky. So there you are. That's now it sounds like the inside of a hard disk. And this whole crackliness is just coming out of the interaction between ULaw and the underlying noises. And without it, this is the real sound we're working with in XRegion. which is pretty darn intense all the same. So we add ULAW and it just becomes a crackly mess. Sort of boxy here. Kind of maximum cancellation here. A little brighter, a little darker. And that's what XRegion all by itself sounds like. So essentially what's happening with this kind of stuff, ULAW is exaggerating the differences between this and dry. Like if we have that mid-ranginess, but it's also saturated and louder than normal. You law it and we get all the mid-ranginess and even more louder than normal. It's exaggerating whatever departure there is from dry-wet. That's what it's for. And the end result is a sort of more gnarly industrial alien transmission kind of thing. Whereas the raw plugin is doing this. It's focusing things down into the region that we're working with. And then, in honor of how I saw David at the beginning of the stream, we're throwing ULAW in. Let's try it out on something completely different, like a rock song that I did, or at least the beginning of one. I think this is not all of it. you out. It's like unrecognizable. You can't even hear that there are guitars there. Any further experiments? I've done drums. There's not a lot of point of running sine waves into this or anything like that. Oh, I'll play an Alien Kitten song directly. Sounds like this. It's on my media file somewhere, but I don't remember where. It was made in a cell phone. It's a sort of tracker-based song made in a cell phone. I think I got the drums in there somehow. One of many things like this I've done. Been busy for the last couple of weeks, and it wasn't just getting the COVID shot, getting over the second version, the second dose of the Moderna kicked my butt for a few days. I also had to install a ventilation fan so that when it gets really hot I can survive that. I think that is the drum samples, yes. And I also had to repair my subwoofers because I had thrown so much crazy low bass and noise into them that I had thrown so much noise and low bass into them that they broke, and I had to take them apart and kind of reposition them. They're built with a woofer and then another woofer facing it isobarically, and the surrounds of the woofers were buzzing against each other. And also, I had run so much energy into these subwoofers that the wires had rattled loose, and so the wires weren't making a firm connection, so there was these loud buzzing noises happening all the time. So I had to redo that, and that's what you're hearing some of the time on these coding streams. And anytime you're hearing bass, it's that subwoofer doing it and making it very loud indeed. I don't understand what you mean by has a circle running. In particular, tube disks should be very simple. Yeah, so one of the problems with this song is it just keeps going, and this is basically all it does. It just does this for 7 minutes. The songs that I grew up listening to and enjoying that went for, 7, 8, 12, 18 minutes were always much more complicated than that, and I haven't done a very good job of learning how to do arrangements and make more stuff happen. It's that thing that I think it's not an uncommon thing where you're doing music and you get something working and go, okay, great, let's repeat this a lot and then play it for a really long time because this is what I did today and I don't feel like working a whole other day just for another piece of the song. So these are the discipline things that one learns about. Let's shut down Alien Kittens, and I'm going to call XRegion a success. Seeing as I spent the last half an hour making completely heinous noises with it, I think this is going to work. That should be fun. And yeah, bro, as far as the way that these plugins are shown in the DAW, I literally have no control over any of that. That's entirely how the DAW runs things. So the important thing is whether the DAW is running the plugin and making sound with it, because what's being shown on the screen is entirely the DAW's doing. None of it is what the plugin is doing. And I'm not sure whether the M1 machines have OpenGL available. I suppose maybe they do, but I wouldn't be looking for that. I know that the systems layer for graphics on modern Macintoshes is more along the lines of Metal. Before then it was Quartz, Quartz Extreme. OpenGL is kind of possible, but the thing about it is that OpenGL, that's a 3D layer. That's something that you'd be doing entirely on the graphics card, mostly for 3D games and 3D modelers. You could draw stuff on DAWs in OpenGL, but I don't think that put it this way, I think it's very unlikely that Logic is using OpenGL in its most recent versions to draw anything. I think that's stupendously unlikely. So it's going to be Logic's graphical glitches drawing its own plugins. I don't know what to tell you beyond that. But what I will tell you is it is 1 o'clock and I feel this has been a pretty productive coding stream. It's always nice when I can make something that has a lot of flexibility. This has a lot of real possibilities as far as doing just industrial noises and wild stuff. So this should make for a good and fun plugin to post next Sunday, and we'll trundle along. I do have other ideas for further things that I can do. Notably, I'm real curious to see whether I could make a high frequency emphasizing plugin based around sandwiching slew only in a couple of instances of biquad low pass, and then have them filter with whatever steepness you need, and then maybe additional resonance. And of course, that depends, because the higher sample rate you go, the less slew only is going to make sense. But we'll see. Like, one possibility is to do a slew only and then have a small time delay involved. Because if it's a time delay, then it can be the same time delay at different sample rates, and that would actually work. And it wouldn't be so much an exciter. Oh, I've already got a high frequency. Like, use acceleration. Acceleration is a better high frequency limiter than anything that you could want. What I'm thinking of is the way that Neve puts a silk circuit into its portico. No, also not Purist Air. And what that makes me think of is how in slew only, I'm essentially slew clipping. And if I'm slew clipping, it makes sense to pre and post filter it like any of my nonlinear stuff that's designed to be aliasing resistant. I've never heard what slew only sounds like with aliasing removed, because I've always assumed, well, it can't have aliasing, but it's a clipper. It's not really just a filter. And if I can put filters in to control the aliasing issue, I can put a resonant frequency on there so that I can have a treble lift at any frequency I choose, and we can dial that in. And then if it's a clipper, it's only referring to the previous sample, which means I could restrict it differently going positive or negative. I haven't really worked this out very well in my head, and so I'm gonna have to think about that more. But if slew only is actually a clipper, as I believe it is, I can make it to be asymmetrical clipper, meaning that it can generate second harmonics on the highs specifically. And that's kind of the trick that's used in the Neve Portico and stuff like that, where they have the silk button. So we'll see whether we can maybe, and I have a use for that too, because the thing is, there's some stuff I get off of my modular synthesizer that I could run into a mix and want to high pass. I'd want to be like, this is a symbol, this needs to only be on tss, tss, tss. And if I could do a high pass like slew only, which is a pretty effective high pass in its own right, but then also include that second harmonic emphasis, that might be real cool. I'm very interested in what's going to come out of that. And then the testing the filtering is just another stage, just another thing to look into. So on that note, I think I'm going to call it a day. I thank you for coming and checking out what's been going on. And I'll catch up with you folks later. Bye-bye.